You are on a ship, not a ship in any sense that the modern person finds comfortable or recognizable. Not a cruise ship with its heated cabins, and its buffet, and its stabilizers that smooth out the Atlantic swell into something the passenger can ignore while eating a third plate of shrimp. Not even a modest modern sailing yacht with its fiberglass hull, and its below-deck sleeping space, and its GPS, and its emergency satellite beacon. You are on a Viking longship in the North Atlantic in November. Take a moment to fully understand what that means. The longship is approximately 25 meters long and 4 meters wide. You can measure its width in about 6 normal human steps. It is built from overlapping planks of oak, the clinker construction that gives the hull its specific, flexible strength. And it is so shallow drafted that it draws barely a meter of water. This is intentional. The shallow draft is the specific engineering feature that allows the longship to cross the open ocean and then sail directly up rivers and beach on coastlines without harbors, which is the combination of capabilities that made the Vikings the specific, terrifying, everywhere at once presence in the early medieval world. The shallow draft also means that the sea is extremely close. In normal conditions, maybe half a meter below the gunwale. In the kind of sea that the North Atlantic produces in November, the sea is not below the gunwale. It is periodically over it, washing across the deck in the specific, cold, emphatic way of water that has covered several hundred miles of open ocean and has arrived with genuine velocity and no particular concern for your continued comfort. The temperature of the water is approximately 4 degrees Celsius. The temperature of the air is approximately 2 degrees Celsius. The wind is coming from the northwest at about 25 knots, which the Beaufort scale classifies as a fresh breeze, and which the person exposed to it without adequate protection classifies as a problem. You are wet. You have been wet for the better part of 3 days. The wool clothing you are wearing, the specific layered combination of the Viking seafarers kit, has been absorbing seawater and spray for the entire duration of the crossing. And while it has not entirely failed in its thermal function, it has been working considerably harder than it was designed to work in the specific conditions of the sustained North Atlantic. November passage. There is no fire. There cannot be a fire. The longship is a wooden vessel with a woolen sail and a deck full of wooden equipment and cargo. And the fire that would provide the warmth that your body is currently requesting with increasing urgency from your brain would also provide the rapid, comprehensive destruction of the vessel that is the only thing between you and the 4 degrees Celsius North Atlantic. The fire is not an option. You need to stay warm without fire. And here is the thing that the mythology of the Viking warrior tends to obscure, because the mythology of the Viking warrior is more interested in the violence than in the thermal management. The people on this ship have figured out how to do it. Not perfectly, not comfortably by any standard the modern person would apply, but adequately, sufficiently, well enough to cross the North Atlantic in November and arrive on the other side, functional enough to do the things they came to do, which, depending on the specific voyage and the specific crew, range from trading to raiding to colonizing to exploring to the various other activities that the Viking Age produced in the specific energetic century and a half of its most intense activity. The knowledge of how to stay warm on a Viking ship without fire is the knowledge of the practical engineer working with the specific materials and the specific constraints of the specific problem. It is the knowledge of the wool and the animal fat and the body heat and the physical activity and the specific social arrangement of the crew that turned a collection of individual bodies into a collective thermal system. It is the knowledge of the shelter construction and the sleeping arrangement, and the specific management of the body's own heat production that the experienced Viking seafarer had accumulated through the apprenticeship of multiple crossings. It is genuinely fascinating knowledge, and nobody makes enough fuss about it. Let's fix that. Chapter 1. The Enemy, Understanding, Cold Water, Cold Air, and Why the North Atlantic was specifically trying to kill you. The North Atlantic is not the Mediterranean. This seems obvious enough to not require stating, but the specific difference between the Mediterranean and the North Atlantic is the specific difference that explains why the Viking approach to open sea survival was so radically different from the approach of the classical Greek and Roman naval tradition, and why the Viking longship and the Viking sailor's kit were the specific engineering achievements of the people who had taken seriously the specific challenge that the North Atlantic posed. The Mediterranean is warm, not warm in the tropical sense, but warm in the sense of the body of water whose average surface temperature in the sailing months is somewhere between 18 and 28 degrees Celsius, whose worst conditions are the manageable conditions of the winter bora or the mistral, genuinely dangerous winds, but in a sea whose temperature is not immediately lethal to the person who falls in. The Greek and Roman sailor who went overboard in the Mediterranean in the summer was the sailor who was cold and frightened and in genuine danger, but who had some time before the cold became the direct cause of death. The North Atlantic is not like this. The North Atlantic surface temperature in the areas where the Viking routes ran, the waters off Norway, the crossing to Iceland, the Iceland to Greenland passage, the Greenland to North America route, is between 2 and 12 degrees Celsius, depending on the location and the season. In November, in the waters between Iceland and Greenland, it is closer to the lower end of that range. The specific physiological consequence of immersion in water at 4 degrees Celsius is the specific, rapid physiological catastrophe of the cold shock and the incapacitation that the cold water produces faster than most people's mental model of drowning suggests. The cold shock response is the first problem, the specific involuntary gasp that the sudden immersion in cold water triggers, the specific massive intake of breath that the cold shock produces in the person whose airways are at or below the water surface. The gasping response to cold water immersion is the specific drowning mechanism that claims the majority of cold water drowning victims, not the exhausted swimmer who can no longer keep their head above water, but the person who gasps water into their lungs in the first moments of the immersion before they have had a chance to assess their situation. The swimming incapacitation is the second problem, the specific progressive loss of the fine, and then the gross motor control that the cold water produces as the extremities cool faster than the body can maintain them. The person who goes overboard in 4-degree water has approximately 3 minutes before their hands are too cold and too uncoordinated to grip a rope if one is thrown to them, before their arms are too cold to maintain an effective swimming stroke, before the specific coordination of the swimming movement becomes impossible. The hypothermia is the third problem. And by the time hypothermia is established, the first two problems have usually already become fatal. But for the Viking sailor who was not in the water, who was on the ship managing the conditions of the crossing, hypothermia was the specific, slow, progressive threat that the management of the clothing and the activity and the sleeping arrangement was designed to prevent. Hypothermia begins when the core body temperature drops below 35 degrees Celsius, the specific threshold below which the physiological processes of the body begin to malfunction in the specific progressive cascade that ends if the temperature drop is not reversed in cardiac arrest. The symptoms of the onset of hypothermia are the symptoms that the experienced sailor learned to recognize in their crewmates: the specific shivering, the specific mental slowing, the specific loss of fine motor coordination, and to address before the progression reached the stages where recovery became more difficult. The cold air was the second component of the thermal challenge. Not as immediately lethal as the cold water, but sustained over a much longer period and in combination with the wind that the passage required. The wind chill, the specific intensifying effect of moving air on the rate of heat loss from the exposed surface, was not a concept that the Viking sailor had a name for, but it was a phenomenon that the Viking sailor understood empirically and managed practically. The exposed face in the 20-knot wind at 2 degrees Celsius was the face losing heat at the rate appropriate to a temperature of approximately minus 14 degrees Celsius. The exposed face for the duration of a North Atlantic crossing was the face that required specific management. The wet clothing was the third component. The specific dramatic reduction in the insulating capacity of the wet textile that transformed the effective insulation of the clothing from its dry value to something dramatically less. Water conducts heat approximately 25 times more efficiently than still air. The wet clothing that was in contact with the skin was the clothing whose moisture was conducting heat away from the body 25 times faster than the dry clothing would have been. And the Viking sailor who was wet through, who had been in the spray and the sea wash for 3 days, was managing the thermal challenge with the clothing whose effectiveness was a fraction of its dry rating. Understanding these three components of the thermal challenge, the cold water's immediate lethality, the cold air's sustained effect, and the wet clothing's reduced effectiveness, is the necessary foundation for understanding why the Viking approach to thermal management on the longship was as sophisticated as it was. These were not people ignoring a minor discomfort. These were people managing a genuine survival challenge with the specific practical intelligence that survival challenges have always demanded of the people who take them seriously. Chapter 2. The Wool. Why Vikings wore what they wore, and why it was smarter than it looked. The wool was doing something the Viking sailor didn't have a name for. The modern textile scientist has a name for it. The specific thermodynamic mechanism by which the wool fiber manages the interface between the human body and the cold, wet environment. But the Viking sailor who wore the wool was wearing it because the empirical observation of multiple generations of people in wet, cold conditions had established that wool worked and that the alternatives worked less well, and that this was the information the sailor required without needing the mechanism's specific explanation. What the wool was doing was something that no other natural fiber does as effectively: managing moisture while maintaining insulation. The specific molecular structure of the wool fiber, the keratin protein structure with its specific scaled surface that the lanolin coating maintains, gives wool the capacity to absorb moisture vapor from the immediate environment without the absorbed moisture reaching the fiber's core in the way that would reduce its insulating effectiveness. The wool fiber can absorb up to 30% of its own weight in moisture before it begins to feel wet against the skin. This is not a minor property. This is the specific, extraordinary characteristic that makes wool the preeminent natural fiber for the cold, wet environment, and that makes the Viking sailors' choice of wool as their primary textile a genuinely, specifically correct technological decision, rather than merely the decision of the people who happened to have sheep. The mechanism is the mechanism of the vapor absorption. The wool's molecular structure absorbs the water vapor that the sweating body produces, preventing the buildup of the damp, still air layer against the skin that is the specific thermal problem of the non-breathing textile in the active environment. The sailor who is rowing or managing the sail in the cold is the sailor whose body is producing heat and moisture simultaneously. These exercise generating the heat that the cold environment is trying to remove, and the moisture that the heat generation produces. The wool absorbs the moisture without losing its thermal effectiveness, maintaining the insulating air pockets in its fiber structure, even as it absorbs the moisture that would collapse the insulating structure of the cotton or the linen. The wet wool is the other specific, important property. The behavior of the wool textile when it is wet through, not merely moisture absorbing, but genuinely saturated by the spray and the sea wash that the November crossing produces. Wet wool retains approximately 60 to 70% of its dry insulating value. The specific retained insulation of the material, whose fiber structure maintains its configuration under saturation in ways that the cotton or the linen does not. The wet cotton loses virtually all of its insulating value, becoming a cold, wet layer against the skin that conducts heat away, rather than retaining it. The wet wool retains more than half of what it does when dry. In the conditions of the North Atlantic crossing, the difference between 60% insulation and 0% insulation is the difference between the manageable and the fatal. The specific construction of the Viking woolen textile was the construction of the people who had spent considerable effort on the specific performance properties of their primary warm weather material. The Norse wool, the wool of the native Nordic sheep, breeds, particularly the Old Norse sheep, whose fleece structure was specifically suited to the cold, wet environment, had the specific fiber characteristics of the double-coated fleece, the outer coat of the longer, coarser guard hairs, and the inner coat of the shorter, finer, more insulating fiber that together produce the textile with the specific combination of water-shedding outer surface and insulating inner layer. The spinning and weaving of the Viking textiles was not the rough, primitive craft of the popular imagination's Norse warrior. The archaeological evidence from the Viking Age, the textile fragments from graves, the weights and tools from settlements, the specific technical analysis of the surviving fabric samples, shows the specific, sophisticated textile production of the culture that had identified the textile as a critical survival technology and had invested accordingly in the quality of its production. The specific weave structures of the Viking Age. Norse textiles, the diamond twill, the broken diamond twill, the tablet-woven borders, were not merely decorative choices. The twill weave creates a specific surface structure with more float in the warp and weft threads than the plain weave, and the longer floats of the twill produce a surface that is more water-resistant than the plain weave, because the water droplets have less of the textile surface to wet and can more easily bead and run off. The experienced Norse textile producer who chose the twill for the outer garment layer was making the specific, technically correct choice for the water-shedding performance of the surface layer. The lanolin was the specific biological contribution to the wool's thermal performance that the Viking sailor exploited, the natural, waxy substance produced by the sebaceous glands of the sheep and present in the raw wool that the commercially available modern wool has typically been washed out of. The lanolin's hydrophobic properties, its specific resistance to water penetration, made the unwashed or lightly washed wool significantly more water resistant than the fully processed wool, and the Viking textile tradition's preference for the less processed wool retained the specific thermal benefit of the lanolin's hydrophobic protection. The layering system that the Viking sailor employed was the specific application of the wool's properties in the configuration that maximized the thermal benefit. The base layer, the linen or fine wool next to the skin, was the moisture management layer, the specific textile that maintained the dry microenvironment against the skin that the body's comfort and the body's thermal efficiency required. The middle layer, the heavier wool tunic and trousers, was the primary insulation layer, the bulk of the textile that trapped the still air that the insulation required. The outer layer, the heavier woolen cloak, the specific outer garment that the Viking seafarer used, was the wind and rain management layer, the surface that the moving air and the spray encountered first, and that shed as much of both as possible before they reached the insulating layers below. Chapter 3. The animal fat, the specific technology that made the difference between the tolerable and the genuinely miserable. The Vikings greased themselves, not in the metaphorical sense of the political operator working the room at the embassy reception, in the yes, specific, practical, literal sense of the people who applied animal fat to their skin and to the surface of their clothing as the specific additional thermal and moisture management technology that the wool's performance alone did not provide in the most demanding conditions. The animal fat, the rendered fat of the domestic animals that the Norse economy produced, primarily the fat of the cattle and the sheep and the pig, applied as tallow or as the specific, more refined preparations that the Norse domestic tradition produced, was the Viking sailor's waterproofing technology and additional skin protection combined in the single substance that the available materials permitted. The application of fat to the skin served two specific functions. The first was the waterproofing of the exposed skin surfaces, the face, the hands, the neck, that the clothing did not cover and that the cold water and the cold air were attacking directly. The fat layer on the skin reduced the rate of evaporative cooling from the skin surface and created a specific, partial barrier against the direct water contact that the spray and the wave wash produced. Not a complete barrier. Fat applied to skin does not create a truly waterproof surface, but a meaningful reduction in the rate of the moisture penetration that reduced the skin's temperature. The second function was the protection of the skin from the specific additive damage of the sustained exposure to cold water and cold air that the long crossing produced. The chapped skin of the unprotected face and hands, the specific, cracked, painful consequence of the repeated wetting and drying and cold exposure that the crossing imposed, was the skin that had lost its natural moisture protection and that the fat application was attempting to supplement. The damaged skin was not merely a comfort issue. The cracked, compromised skin of the chronically cold exposed extremities was the skin that was losing heat faster than the intact skin, and that was more vulnerable to the specific dangerous progression toward frostbite that the most severe cold exposure could produce. The application of fat to the clothing, specifically to the outer layer of the woolen garment, was the waterproofing technology that supplemented the wool's natural resistance to water penetration. The fat-impregnated outer garment was the specific additional moisture barrier that the most demanding conditions required. The garment surface that shed water rather than absorbing it, that maintained the dry interior of the garment system against the sustained spray of the Atlantic crossing. The specific fat that the Viking sailor would have used for this purpose was the tallow, the rendered fat of the cattle or sheep. processed and applied to the garment in the specific domestic operation of the garment maintenance that was part of the preparation for the sea voyage. The tallow impregnation of the outer wool layer was not a casual application. It was a deliberate treatment of the specific garment surface that the severe condition exposure required. The horse fat was the specific application for the skin. The horse tallow, whose specific fatty acid composition made it more effective as a skin lubricant and protectant than the cattle or sheep tallow. The Norse sources that discuss the preparation for the sea voyage mention the skin treatments that the experienced sailor applied, and the horse fat was among the materials that the tradition identified as specifically appropriate for the purpose. The seal fat was the most effective of the available animal fats for the waterproofing application, the specific highly saturated fat of the marine mammal, whose own biological waterproofing requirements had produced the fat with the best hydrophobic properties of the available options. The Norse seal hunters who processed the seal carcass for its various useful components, the evi meat, the skin, the blubber, had access to the specific superior waterproofing material that the seal's biology provided, and the application of seal fat to clothing and skin in the most demanding cold water environments was the specific, technically correct choice. The combination of the wool textile and the fat treatment was the combined technology that the Viking sailors' cold water survival kit represented. Neither element alone being sufficient for the most demanding conditions, but the two elements together providing the specific, adequate protection that the experienced sailor's preparation produced. The well-prepared Viking sailor departing for the North Atlantic crossing was the sailor who had ensured that the clothing was adequately treated and that the fat supply for skin application was part of the voyage's provisions. The bear fat deserves a specific mention, not because it was universally available, but because the Norse sources identify it as the most valued of the animal fats for the cold weather protection application, and the specific status of the bear fat in the Norse thermal management tradition reflects the specific performance advantage that the bear fat provided. The bear's fat, the specific, thick, insulating blubber that allows the bear to maintain its core temperature through the Arctic winter, has the specific fatty acid composition that makes it the most effective natural insulator among the available options. And the Norse hunter who had bear fat available for the voyage preparation was the Norse hunter who was using the highest performance available material. The social dimension of the fat application was the social dimension of the practical collaboration that the close quarters of the longship required in other contexts as well. The application of fat to the back and the shoulders and the areas of the body that the sailor could not reach without assistance was the specific practical reason that the crew's mutual assistance in the preparation process was the expected rather than the exceptional behavior. The crew that helped each other prepare, that assisted with the application of the fat to the difficult-to-reach areas, that checked each other's garment preparation, was the crew that was collectively managing the survival challenge in the specific cooperative way that the challenge required. Chapter 4. The Body Heat. How the Vikings turned rowing into a heating system. The oar was a furnace, not metaphorically, thermally. The specific physical work of rowing the Viking longship was the specific metabolic heat, generation of the sustained muscular effort that the body performed when it drove the oar through the water, and the sustained metabolic heat generation of the rowing crew was the primary active heating technology of the vessel when the wind was insufficient or the wrong direction. The specific physics of the metabolic heat generation are Straightforward. The human body performing sustained physical work converts the chemical energy of the food it has consumed into the mechanical work of the muscular contraction and the heat that the inefficiency of the muscular contraction produces. The efficiency of the human body as a mechanical work converter is approximately 25%. The remaining 75% of the energy input becomes heat. The person rowing hard, sustaining the effort of the full, long rowing stroke at a pace that the long crossing required, was generating approximately 400 watts of metabolic heat, roughly equivalent to 4 standard incandescent light bulbs running simultaneously. A longship with a crew of 40 rowers, all rowing hard, was generating approximately 16 kilowatts of metabolic heat. This is not a trivial amount of thermal energy. In the specific, contained environment of the longship, not enclosed, but with the crew bodies close together in the rowing positions, with the sail above and the hull below partially blocking the wind. This heat generation was the difference between the crew that was maintaining its core temperature and the crew that was not. The specific strategic management of the rowing in the thermal context was the management that the experienced ship's commander conducted with the awareness of the crew's thermal state as much as its mechanical requirement. The rowing that was required when the wind failed was also the rowing that prevented the crew from cooling to the dangerous range. The rest period that the wind allowed was also the cooling period that the careful commander managed by ensuring that the resting crew were adequately covered and sheltered from the wind during the rest, returning to the oars before the cooling had progressed to the point of compromising the crew's subsequent performance. The rotation of the rowing crew was the specific thermal management strategy of the longships. Extended passage, the division of the crew into rowing watches that alternated between the active rowing that generated the heat and the rest that allowed the recovery of the muscular effort without allowing the excessive cooling. The watch length was calibrated, not with the modern precision of the stopwatch, but with the empirical calibration of the experienced commander to the specific balance of the work and the rest that maintained both the mechanical output and the thermal maintenance of the crew across the duration of the crossing. The positioning of the rowers in the rowing configuration was the specific social and thermal arrangement that the longship's layout required. The rowing benches, the thwarts on which the rowers sat, were the primary occupied positions of the working crew, and the specific configuration of the rower's body in the rowing position was the configuration that the work required, the back and the arms providing the power for the stroke, the legs providing the base and the leverage, the core engaging to transfer the power from the legs through the upper body to the oar. The rowing position was also a thermal position. The rower who was fully engaged in the rowing stroke was the rower whose entire musculature was active, whose full metabolic rate was elevated, whose heat generation was at its maximum. The rower who was taking a longer rest stroke, recovering between the full power applications, was the rower whose heat generation had dropped from the maximum, but remained significantly above the resting level. The crew that was rowing maintained its thermal output at the level that the combination of the clothing insulation and the metabolic heat generation produced the adequate thermal balance. The termination of the rowing, the change from the rowing to the sailing that the favorable wind permitted, was the specific thermal transition that the experienced crew managed with the specific preparations that the transition required. The rower, who had been generating 400 watts of metabolic heat and who stopped rowing immediately, entered the specific physiological situation of the elevated body temperature beginning to drop as the metabolic rate returned toward the resting level, while the wet clothing that the rowing's perspiration had added moisture to continued to conduct heat away from the body at the rate of the wet textile. The management of this transition, the wrapping of the resting crew in the available covering material, the movement to the more sheltered positions of the ship, the specific physical arrangements that reduce the wind exposure of the cooling body, was the specific practical crisis management of the longship's thermal operations. The crew that understood this transition and prepared for it was the crew that avoided the rapid post-rowing cooling that could move from comfortable to dangerous in the specific short period of the wet clothes. Wind-exposed body losing heat faster than the resting metabolism could replace it. The specific food management of the rowing watch was the thermal management of the fuel supply for the metabolic furnace. The food that the Viking sailor consumed during or immediately before the rowing watch was the food that sustained the metabolic heat generation that the rowing required. The calorie-dense foods that the Norse provisions included, the dried fish, the hard cheese, the ship's biscuit, the dried meat, were the specific high-energy foods whose rapid conversion to metabolic fuel maintained the heat generation that the rowing required and the thermal balance that the crossing depended on. The warming effect of the food was the dietary thermogenesis that the previous script's medieval castle chapter discussed in a different context, but in the longship context, it was managed with the specific tactical awareness of the experienced crew that understood the food as the fuel for the body's furnace as much as for the body's mechanical requirements. The crew member who ate before their rowing watch, who consumed the calorie-dense provisions that would maintain the metabolic rate through the rowing effort, was the crew member who was most effectively managing their own thermal situation. Chapter 5. The Sleeping. How 30 people on an open deck slept without freezing to death. The sleeping arrangement was a thermal technology. Not primarily, it was also a practical arrangement for the limited space of the vessel and the social arrangement of the crew. But the thermal function of the sleeping arrangement was so fundamental to the crew's survival on the extended passage that the specific practical choices of where and how and with whom the Viking sailor slept were the choices of the thermal engineer as much as the social creature. The sleeping skin was the specific, dedicated sleeping equipment of the Viking seafarer. The reindeer skin, or the bear skin, or the seal skin, or the heavy wool blanket that the sailor brought aboard as their personal sleeping equipment, the specific thermal envelope that the sleeping body required for the night that was colder than the day's active period. The sleeping skin was one of the Viking sailor's most important personal possessions on the voyage, its quality and its condition directly affecting the quality of the sleep that determined the sailor's capacity to function on the following day. The reindeer skin was the specific preferred sleeping skin of the Norse seafarer who had access to it. The specific thermal properties of the reindeer hide, whose hollow hair structure provided the insulation of the air-trapping fiber at the microscopic scale, producing the specific, very effective insulation of the material that the reindeer's own thermal requirements had biologically optimized. The reindeer of the northern Scandinavian regions had evolved the specific, dense, hollow hair, coat that allowed them to survive the Arctic winter, and the sleeping skin made from that coat transferred the reindeer's biological thermal solution to the human who slept in it. The sealskin sleeping bag was the highest performance sleeping equipment available to the Viking seafarer who had access to it. The specific, water-resistant outer surface of the sealskin combined with the insulating inner layer, producing the sleeping arrangement that the wet deck environment could not easily penetrate. The sealskin's natural waterproofing, the same biological waterproofing that allowed the seal to maintain its body temperature in the cold water, was a specific advantage of the marine mammal's skin as the sleeping bag material for the marine environment. The positioning of the sleeping crew on the longship was the positioning of the thermal economy of the vessel's limited covered space. The sleeping crew was arranged in the specific configuration that the ship's layout permitted and that the thermal economy recommended, the people sleeping together rather than apart. The body warmth of the sleeping mass, contributing to the thermal balance of the sleeping group in ways that the individual sleeping body could not achieve alone. The shields were the specific dual-purpose equipment of the Viking longship that served both the combat function and the sleeping function in the specific way of the limited space vessel that needed every major piece of equipment to serve multiple purposes. The shields that lined the sides of the longship in their storage position hung along the gunwale in the configuration that the longship's side racks allowed, were the specific windbreak that the sleeping crew deployed to reduce the wind exposure of the deck sleeping space. The tent cloth, the specific large piece of heavy wool or linen that the longship carried as one of its essential non-combat pieces of equipment, was the primary overnight shelter of the crew deployed over the central portion of the vessel to create the specific covered sleeping space that the exposed deck would not provide. The tent cloth was supported on the oars. The oars shipped for the night and used as the tent frame, their length providing the ridge pole and the supporting structure that the tent cloth required. In the specific, efficient use of the available materials for the multiple purpose configuration, the tent cloth's thermal function was the specific windbreak function, reducing the wind that the exposed deck would have subjected the sleeping crew to, and creating the enclosed airspace that retained the collective body heat of the sleeping crew in a way that the open deck could not. The tent cloth was not a warm shelter in any modern sense. It was not insulated. It was not sealed against the cold air. But it was a specific reduction of the wind chill that transformed the sleeping environment from genuinely dangerous to merely very cold. The communal sleeping under the tent cloth was the communal sleeping of the thermal strategy, the specific arrangement of the crew under the single covering that the collective body heat of the group maintained at a significantly higher temperature than the individual sleeping arrangement could achieve. The physics were the same physics that the medieval Great Hall's communal sleeping exploited. The multiple bodies in the enclosed space, their collective metabolic heat accumulating in the smaller volume to produce the warmer microenvironment that the individual could not create alone. The specific social arrangement of the sleeping group reflected both the social hierarchy of the crew and the thermal logic of the arrangement. The sleeping in pairs or in small groups, the specific pairing of the crew members for the night watches and for the sleeping rotations, was the specific social arrangement that the confined space required and that the thermal logic endorsed. The pair of sleeping bodies generated twice the individual's heat in the same enclosed space of the sleeping skins, and the warming of the shared sleeping arrangement was the specific practical benefit that the social arrangement of the paired sleep provided. The watch rotation for the sleeping crew was the specific thermal compromise of the passage management. The division of the crew into the sleeping watches and the working watches that maintained the vessel's management through the night, while allowing the maximum portion of the crew the maximum sleeping time that the vessel's management permitted. The sailor whose watch ended and who entered the sleeping space. The tent cloth area, the paired sleeping skin arrangement, was the sailor transitioning from the active heat-generating work of the watch to the passive heat-conserving management of the sleep. The transition management was the specific critical thermal moment of the watch change. The sailor. Coming off watch was the sailor whose body had been generating elevated heat through the active watch period and who was now transitioning to the resting metabolism of sleep. The wet, cold clothing of the watch period was the clothing that needed to be managed, supplemented with the additional covering of the sleeping skin, the specific positioning of the body in the most sheltered part of the sleeping space, before the resting metabolism's reduced heat generation left the cooling body without adequate thermal protection. Chapter 6. The food. What Vikings ate on the ship and why every meal was a heating decision. The provisions were chosen for warmth as much as for nutrition, not in the specific sense of the modern sports nutritionist advising on the optimal macronutrient split for the endurance athlete's energy requirements, in the specific empirical sense of the experienced Norse provisioner who had learned through multiple voyages which foods maintained the crew's performance in the cold, wet conditions of the North Atlantic crossing, and who stocked the provisions accordingly. The fat was the thermal fuel of the Viking sailor's diet, not the incidental component of the foods that happened to contain it, but the specifically sought, specifically valued component of the provision that the Norse dietary tradition identified as the primary fuel for the cold weather performance. The fat's specific caloric density, 9 calories per gram compared to 4 calories per gram for carbohydrate and protein, made it the most energy-dense food available, and the specific physiological role of fat in the sustained cold weather exertion made it the most thermally relevant food component in the conditions of the North Atlantic crossing. The dried fish, the scray, the air-dried Atlantic cod, that was one of the Norse economy's most important commercial products, was the primary protein provision of the longship stores. The dried fish was the specific provision of the sea voyage for multiple practical reasons. Its preservation by drying required no refrigeration. Its compact form made it storable in the limited space of the vessel. Its high protein content provided the specific sustained metabolic fuel that the crew's physical demands required. But the dried fish was also the thermal provision, the high protein content whose specific metabolic processing produced the elevated heat generation of the dietary thermogenesis that was highest for protein among the macronutrients. The crew that ate dried fish before the rowing watch was the crew that was fueling both the mechanical work of the rowing and the thermal generation of the protein metabolism simultaneously. The skyr, the specific strained dairy product of the Norse tradition that resembled the modern yogurt in its consistency, but whose specific high-protein, high-fat composition made it the specific calorie-dense fermented dairy provision that the voyage stores included was the thermal provision of the dairy component. The skyr's high fat and protein content made it the most calorie-dense of the dairy provisions, and its fermented preservation made it stable for the duration of the crossing without the spoilage that the fresh dairy would have produced. The flatbread, the specific, unleavened bread product of the Norse baking tradition, made from the grain that the provisions included and cooked on the hot stone or the iron pan that the shore cooking facilities had prepared, was the carbohydrate provision of the voyage. The flatbread's specific compact form and its durability without spoilage made it the practical bread provision of the sea voyage, and its carbohydrate content was the rapid fuel component of the diet that the crew's energy requirements demanded in the periods of intense physical work. The dried meat, the specific preserved meat that the Norse preservation tradition produced through The drying and the salting that extended the meat's shelf life for the voyage duration was the additional protein and fat provision that supplemented the dried fish in the provision stores. The dried meat's fat content was typically higher than the dried fish's. The terrestrial animals of the Norse economy had the fat reserves that the lean cod did not. And the specific higher fat content of the dried meat was the specific thermal advantage that made it the preferred provision for the coldest, most demanding crossing conditions. The dried berries and the preserved fruits, the lingonberries and the cloudberries, and the various other northern fruits that the Norse food preservation tradition dried and packed for the voyage, were the vitamin provision of the crossing that the specific anti-scurvy function of the vitamin C content made the critical health provision of the extended passage. The Norse sailor who had adequate vitamin C provision was the sailor whose connective tissue maintained its integrity through the crossing, whose immune system had the specific micronutrient support it required, and whose overall physical resilience to the cold and the exertion of the crossing was maintained at the level that the vitamin-sufficient body achieved. The water provision was the specific logistical challenge of the Norse sea voyage. The fresh water that the crew required for drinking, carried in the wooden casks that the vessel's provision stores included. The specific practical limitation of the water provision was the limitation that determined the maximum duration of the unsupported crossing. The amount of water that could be carried in the cask provision determined how long the vessel could remain at sea without access to a freshwater source. The water was not hot. There was no fire to heat it on the longship. The specific thermal comfort of the hot drink, the hot tea, the hot soup, the specific immediate warming of the body that the hot liquid provided was not available to the Viking sailor on the open ocean. The water drunk at sea temperature, a few degrees above the ambient air temperature, which was a few degrees above zero, was the cold water of the provision, and the specific contrast between the cold water of the longship and the hot drink of the shore encampment was one of the specific sensory markers of the difference between the sea and the land. The ale and the mead were the provisions of the shorter crossing, and the feasting occasion rather than the sustained provision of the long Atlantic passage. The fermented beverages that the Norse festive tradition valued, and that the sea voyage included in the shorter form, but that the extended provision stores of the serious ocean crossing could not carry in quantity. The specific vasodilating effect of the alcohol that we discussed in the fat chapter's context was the specific paradoxical thermal effect that the experienced Norse seafarer had learned to manage, the warmth feeling of the drink that was the skin temperature increase rather than the core temperature maintenance. Chapter 7. The Shelter. How Vikings built temporary protection on the open deck and what it actually achieved. The tent was not a tent in any sense the modern camper would recognize. The modern camper's tent is the engineered shelter, the specific design structure of the modern outdoor equipment industry, with its waterproof fly, and its breathable inner, and its sealed floor, and its structural poles, and its guy rope system, and its specific thermal rating that the manufacturer has calculated based on the minimum temperature at which the sleeping occupant will maintain adequate comfort. It is a designed product. It is tested. It has specifications. The Viking sailor's shipboard shelter was not this. It was the specific improvised multi-purpose configuration of the available materials, the tent cloth and the oars and the shields and the rigging and whatever else the specific situation of the specific vessel permitted, assembled in the specific way that the experienced crew had learned to assemble it for the specific conditions of the specific night. It was the shelter of the people who had thought very carefully about how to use what they had, rather than the shelter of the people who had designed a product for the purpose. The tent cloth, the specifics of which we touched on in the sleeping chapter, was the most important single piece of the shipboard shelter. The archaeological evidence for the Norse tent cloth comes primarily from the grave finds. The Oseberg ship burial, the Gokstad ship burial, that included the tent materials among the buried equipment, and the specific analysis of those materials provides the specific physical evidence of what the Norse tent cloth was and how it was constructed. The Gokstad ship burial tent material, one of the better preserved thin examples from the archaeological record, shows the specific heavy wool textile of the Norse tent construction, the weave structure, and the fiber preparation that produced the specific weather-resistant properties that the tent required. The wool of the tent cloth was the heavier, more densely woven wool of the specific outer layer performance requirement. The textile that needed to shed water rather than merely manage it, to resist the sustained rain and spray of the extended offshore passage. The deployment of the tent cloth on the longship was the deployment of the shape that the oar supports permitted. The longship's oars, when shipped for the night, pulled in from the rowing position and stowed, provided the natural structural members for the tent frame. The oar shafts, propped at their midpoints on the vessel's cross structure and leaning against the upper strakes of the hull, created the specific ridgepole arrangement that the tent cloth was draped over to create the covered space that the sleeping crew occupied. The specific shape of the tent thus created was the shape of the vessel's limited configuration: low, narrow, occupying the center portion of the vessel's length, while leaving the bow and the stern accessible for the watch crew's management of the vessel. The tent space was not a comfortable standing height. It was the crawling and lying down height of the shelter that provided the windbreak and the rain cover without the luxury of the standing space that the modern camper's tent assumes. The shield's role in the shelter construction was the specific additional windbreak function that the shields deployed along the tent's open sides provided. The shield, the round wooden shield of the Viking warrior, was a substantial piece of equipment whose diameter of approximately 80 centimeters made it a meaningful windbreak when deployed vertically along the tent's side. The shields hung from the tent cloth's edge or propped along the hull's inside surface created the specific additional wind barrier that reduced the airflow into the tent space and maintained the accumulated body heat of the sleeping crew within the shelter. The specific thermal performance of the combined tent cloth and shield windbreak arrangement was the performance of the rough but effective enclosure, not the sealed, insulated enclosure of the modern tent, but the specific, adequate reduction of the wind speed and the direct exposure that transformed the sleeping experience from the open deck exposure to the more manageable, protected space experience. The wind speed inside the tent arrangement was a fraction of the wind speed outside it, and the specific reduction of the wind chill that this produced was the specific, meaningful improvement in the crew's thermal situation during the sleeping period. The bow and the stern of the longship provided the additional natural shelter positions that the experienced crew exploited for the watchkeeping during the worst weather. The specific raised structure of the longship's bow and stern, the specific curved profiles of the stem post and the stern post that gave the Viking longship its characteristic, dramatic silhouette, also created the partial shelter of the wind shadow that the structures produced on their lee side. The crew member, keeping watch in the worst conditions, positioned themselves in the lee of the stem post or the stern post, the specific partial shelter of the wind shadow that the raised structure created, and used the stem post or the stern post itself as the specific physical windbreak against which they could press their back, reducing the wind exposure of the back surface that was the largest surface of the crouching or sitting watchkeeper's wind-exposed area. The sail, when deployed, was the primary wind management technology of the longship, but when furled for the night or in the conditions that required the furled sail, it became the additional covering material that the crew could deploy for supplementary shelter. The Norse sail, the large square sail of the longship, made of the heavy wool or the specific woven walrus hide material that the most demanding performance applications required, was when furled a substantial mass of textile that could be arranged to provide additional cover or windbreak for the sleeping crew. The specific creative use of the sailcloth for shelter during the periods when the wind made sailing impossible was the specific improvisational skill of the experienced crew. The ability to see in the equipment the multiple uses that the limited space vessel required every major piece of equipment to serve. The sail that was also a blanket, the oar that was also a tent pole, the shield that was also a windbreak. The multiple use thinking of the Viking seafarer was the specific practical intelligence of the person who had understood that the limitation of space required the maximum versatility of every carried item. Chapter 8. The Mind. How Vikings used culture, ritual, and psychology to manage the cold. The cold was partly in the head. Not entirely. The physics of the heat loss were real, and the physiology of the hypothermia was real, and the death that insufficient thermal management produced was genuinely and completely physical. But the specific psychological dimension of the cold's management, the way that the mind's experience of the cold amplified or reduced its physiological impact, the way that the specific cultural frameworks of the Norse tradition managed the cold's psychological challenge, was the dimension of the Viking thermal management that the physical account of the wool and the fat and the rowing tends to omit. The Norse mythological framework was not incidental to the thermal management of the sea voyage. It was the specific cultural technology that transformed the experience of the cold and the danger from the paralyzing experience of the purely physical challenge to the meaningful experience of the culturally framed test. The cold was Niflheim, the specific Norse cosmological framework that placed the realm of ice and cold and darkness at one of the foundational poles of the Norse cosmos. Niflheim, the realm of mist and cold, the primordial cold from which the creation had emerged, was the framework that made the cold not the random, indifferent physical challenge of the modern naturalistic worldview, but the specific, meaningful encounter with the cosmological principle that the Norse universe was organized around. The Norns wove the fate, the specific Norse theological understanding that the course of each person's life was woven by the Norns, the three figures who spun and wove and cut the thread of fate at the well of Urdr, was the theological framework that made the outcome of the voyage the predetermined fate that the specific personal qualities of courage and endurance and skill could navigate toward the best available outcome, but could not override if the Norns had woven differently. This framework had a specific psychological function in the cold. It reduced the specific catastrophizing anxiety of the person who is calculating the odds of survival and finding them uncomfortably low. The Skald tradition, the specific Norse poetic tradition of the court poet who composed and performed the formal poetry that the Norse aristocratic culture valued above most other artistic productions, was the cultural technology of the morale management on the sea voyage. The Skald who could compose the kenning, the specific compressed metaphorical description that the Norse poetic tradition required for the storm that was threatening the vessel, transforming the physical threat into the artistically managed experience of the culturally framed description, was the skald who was performing the specific, psychological service of the person who names the thing, and thereby reduces its power. The kenning for the sea was never simple in the Norse poetic tradition. The sea was the whale road, and the swan's way, and the gull's field, and the gray expanse, and a dozen other specific, metaphorical framings that each brought a different dimension of the sea's character into focus. The kenning for the cold was the kenning that gave the cold the specific cultural identity that the Norse tradition required for the things that mattered. The cold was the winter's bite, and the frost giant's breath, and the specific personified entity that the Norse mythological framework populated the natural world with. The saga tradition, the specific prose narrative tradition of the Norse that preserved the accounts of the great voyages and the great warriors in the form that the culture transmitted from generation to generation, was the cultural technology of the peer comparison that the cold's management required. The sailor who knew the saga of Eric the Red's Greenland voyage, who knew the specific, detailed account of the conditions that the first Greenland colonists had endured, who knew that those people had survived and had built a settlement that lasted for centuries. This sailor had the specific cultural data point that the cold's management was possible, that the people who had come before had managed it, and that the specific techniques and the specific attitudes that the saga described were the techniques and the attitudes that the current cold required. The drinking culture of the Norse, the specific mead hall tradition of the communal drinking that the Norse aristocratic social structure organized around, was not directly available on the longship in its full shore-based form. But the cultural values that the drinking culture transmitted, the values of the shared endurance, the communal courage, the specific social reinforcement of the individual's willingness to face the difficult thing, were the values that the crew brought aboard from the shore culture and that sustained the specific collective morale of the crossing. The boasting tradition, the specific Norse custom of the formal boast, the public commitment to the specific brave act that the warrior would perform in the coming engagement or voyage, was the cultural technology of the commitment device that the psychological research on self-regulation has subsequently validated as the effective technique for maintaining the difficult behavior. The warrior who had publicly committed to the specific courageous act was the warrior whose social identity was now bound to the performance of that act, whose retreat from it would cost the specific social capital that the Norse culture made the primary currency of the aristocratic identity, the specific humorous dimension of the Norse cultural response to hardship, the specific, self-deprecating, often very funny account of the terrible conditions that the Viking tradition produced in the saga literature and in the skaldic poetry, was the cultural technology of the humor that manages the difficult by treating it as the amusing. The saga's account of the crossing that was genuinely miserable, but that the author describes with the specific dry wit of the person who has survived it and found it eventually funny. This was the specific psychological technique of the retrospective reframing that made the experience manageable in the telling, and the telling made the next experience feel manageable in the living. Chapter 9. The crew, how the social organization of the longship was itself a thermal technology. The crew was not 40 individuals. It was a thermal system. The specific social organization of the Viking longship crew, the hierarchies and the watch rotations, and the work allocations and the sleeping arrangements and the food sharing and the specific collective management of the vessel was the social technology that transformed 40 individuals into a collective thermal unit that was more resilient to the cold than any of the 40 could have been alone. The concept of the phalagi, the specific Norse legal and social concept of the ship companion, the person who shared the vessel's space and resources and risks and profits, was the specific social technology that defined the crew's relationship to each other and to the voyage. The phalagi were bound by the specific obligations of mutual support and mutual sharing that the Norse ship companion tradition required, the obligation to share the resources, to assist in the emergency, to maintain the collective effort that the vessel's management demanded. The specific thermal implication of the phalagi relationship was the obligation of the warm to assist the cold, the expectation that the crew member who had the resource that another needed would share it, and that the refusal to share was the specific social failure that the crew's code condemned. The sailor who hoarded their sleeping skin when the crewmate was dangerously cold was the sailor who was failing the specific social obligation of the ship companion in the way that the Norse culture found genuinely objectionable. The watch captain, the specific leadership figure of the watch rotation, who had the responsibility for the watch crew's performance and welfare during their period on the vessel's management, was the specific thermal management supervisor of their watch period. The watch captain who monitored the crew's thermal state, who noticed the specific signs of the cold's progressive effect, and who intervened before the dangerous threshold was reached. Was the watch captain performing the specific thermal welfare function that the position required alongside its navigational and mechanical functions? The specific signs of the problematic cold that the experienced watch captain was trained to recognize were the signs that the Norse seafaring tradition identified through the accumulated experience of the crossings. The shivering that was becoming the sustained, uncontrolled shiver of the hypothermia onset, rather than the manageable shiver of the ordinary cold response. The mental slowness of the person whose core temperature had dropped to the range where the cognitive function was impaired. The specific, uncoordinated movement of the person whose extremities had cooled past the functional threshold. The response to the recognized thermal problem was the specific practical intervention of the ship companion, the additional covering material applied to the cold crew member, the active warming technique of the body heat transfer that the Norse tradition had developed, the specific reallocation of the watch duties that allowed the cold crew member to move to the more sheltered position of the sleeping space, while the less cold crew member took the more exposed position. The body heat transfer was the specific direct thermal technology of the severe cold emergency. The person who was dangerously cold placed between or beside the warm crew members whose body heat was the most immediately available thermal resource. The specific physical arrangement of the multiple bodies around the cold person, the human warming arrangement of the experienced cold water survival tradition, was the specific, effective technique for the rapid transfer of the body heat from the warm bodies to the cold body that the severe hypothermia emergency required. The hierarchy of the longship crew was the hierarchy of the specific practical management that the vessel required, rather than the arbitrary status hierarchy of the shore-based social system. The ship's captain, the steersman, the person who controlled the steering oar, and who had the navigation and the overall management responsibility, had the specific authority of the sea captain that the crew recognized as legitimately requiring the obedience that the vessel's management demanded. This authority was not the authority of the shore-based lord. It was the authority of the specific practical competence that the dangerous environment required and that the crew endorsed because their survival depended on it. The specific thermal authority of the ship's captain was the authority to manage the crew's thermal resources as the crossing's conditions required, to order the additional rowing when the crew's temperature required the heat generation rather than the rest, to allocate the available shelter space to the most vulnerable crew members, to decide the watch rotation timing based on the thermal assessment of the crew's state rather than the arbitrary schedule that the convenience might otherwise impose. The social cohesion of the longship crew was the thermal technology of the collective management. The crew that trusted its captain's judgment was the crew that followed the thermal management instructions that the captain issued. The orders to row when the crew would have preferred to rest. The orders to share the sleeping skin with the cold crewmate. The orders to maintain the tent cloth arrangement in the conditions that made the maintenance difficult. The crew that followed these orders was the crew that arrived at the destination with the thermal management that the collective discipline had maintained. The crew that did not was the crew that arrived, if it arrived, with the attrition of the individuals whose thermal management had failed. Chapter 10. The horses, the specific animal thermal technology that the Vikings brought on some voyages. The horse was a furnace on legs, not the primary or the most important thermal technology of the Viking longship, but a specific, documented, occasionally present component of the thermal landscape of the longer voyages that the horse and transport required, and a specific, interesting example of the way that the Viking thermal management thinking identified and exploited every available heat source. The Norse colonization voyages, the specific voyages of the settlers who brought the livestock of the new settlement to Iceland and Greenland, and wherever else the colonization enterprise required, were voyages that included horses and cattle and sheep and the various other animals that the new settlement needed. The animal transport on the longship was the specific practical challenge of loading and securing and managing the livestock in the confined space of the vessel for the duration of the crossing. The animals generated heat. This was not the primary reason they were brought. They were brought because the settlement needed them, but it was the specific incidental thermal benefit of the animal cargo that the experienced colonist recognized and managed. The horse generating 500 watts of metabolic heat standing in the central section of the vessel was a horse contributing 500 watts to the thermal budget of the vessel's environment in ways that the cargo that was not a warm-blooded animal could not. The positioning of the animals within the vessel was the specific thermal management decision that the experienced Viking colonist made with the awareness of the animal's heat contribution. The animals positioned in the central section of the vessel, the most sheltered position, where the tent cloth provided the most effective cover, were the animals whose heat contribution was most efficiently retained within the covered space that the crew also occupied for sleeping. The specific arrangement of the sleeping crew around the animal cargo was the specific practical configuration of the colonization voyages' overnight thermal management. The crew sleeping in the warmth that the animal's body heat had contributed to the enclosed tent space, the animal providing the specific passive heating that the crew's own bodies supplemented with their collective metabolic output. The tent space shared with the horses and the cattle was warmer than the tent space of the crew alone, and the experienced colonist who had made the voyage before knew this and arranged the sleeping position accordingly. The horse's wool, the winter coat of the Norse horse, whose fiber structure provided the same insulating function as the human wool textile, in its biological context, was a thermal resource that the Viking seafarer could exploit in the specific emergency context of the crossing that had consumed the available human clothing's thermal capacity. The person who pressed against the horse's body, the specific direct contact with the warm body surface of the large animal, was experiencing the specific heat transfer of the warm body to the cold body that worked in either direction of the size differential. The specific care of the horses on the crossing was a thermal care, as much as the nutritional. The horse that was cold was the horse that was consuming its feed to maintain its core temperature rather than to maintain its body condition. And the experienced horse manager who recognized the cold horse and provided the additional covering of the available horse blanket or textile was managing both the animal's welfare and the animal's thermal contribution to the vessel's environment. Chapter 11. The Shore Stop. Why landing was the thermal reset and how it was managed. The fire on the shore was the most beautiful thing in the world. Not in the aesthetic sense, not the specific beauty of the sunset or the dramatic coastline, or the specific visual appeal of the Norse landscape that the modern photographer values. In the specific physiological sense of the heat source that the cold, wet body had been deprived of for the duration of the crossing, and that the landfall and the shore fire provided with the specific, immediate intensity of the thing whose value is fully understood only in its absence. The Viking crossing was not the continuous, uninterrupted passage of the modern ocean voyage. The longship's range was limited by the water provision and by the crew's endurance, and the specific planned and opportunistic shore stops of the Norse voyage were the specific thermal resets that the crew required to continue the extended passage. The shore stop was the fire, and the hot food, and the dry sleeping, and the specific, comprehensive thermal recovery that the vessel's open deck crossing had depleted. The specific management of the shore stop was the management of the thermal recovery, as much as the management of the vessel's needs. The first priority upon landing was the fire. The specific, immediate establishment of the shore fire that the warming of the crew required. The dried wood, or the peat, or whatever the specific landing location's fuel provided, was the fuel of the fire that the crew's shivering bodies were asking for, with the specific biological urgency of the body, whose core temperature had been maintained at the edge of the comfortable range for the duration of the crossing. The fire management of the shore stop was the fire management of the experienced outdoor cook and the experienced cold weather survivor combined. The rapid establishment of the adequate fire from the available fuel, the specific management of the fire's heat, for the multiple simultaneous functions of the warming of the crew, the cooking of the hot meal, the drying of the wet clothing, and the heating of the stones for the specific thermal uses that the heated stone technology provided. The hot meal of the shore stop was the thermal event as much as the nutritional one, the specific immediate warming of the body's core through the ingestion of the hot food that the fire could now produce, the hot soup or the hot porridge, or whatever the specific provisions and the specific fire management of the landing site allowed. The hot meal of the landing was the immediate thermal benefit that the cold water provisions of the crossing had not been able to provide, and its specific warming effect on the crew's core temperature was both physiological and psychological. The drying of the clothing was the specific thermal preparation for the next section of the crossing. The re-establishment of the clothing's full insulating capacity that the crossing's sustained wetting had reduced. The wet wool hung near the fire, not too close, which would char the fiber, not too far, which would extend the drying time beyond the available shore stop duration. Was the clothing's specific necessary thermal maintenance that the shore stop's fire allowed, The sleeping on the shore was the thermal recovery sleep, the specific, deep sleep of the body that had been managing the cold crossing's thermal challenge, and that the shore's shelter and warmth now permitted to relax the specific sustained muscular tension of the cold management. The crew that slept on the shore was the crew that was recovering not just from the fatigue of the rowing and the watchkeeping, but from the sustained, energetically expensive cold management that the crossing had required. The reprovisioning of the shore stop, that was the thermal reprovisioning, as well as the navigational pause. The restocking of the water casks that the crossing had depleted. The replacement of the provisions that the crew had consumed, and the specific additional procurement of the fuel and the food that the next section of the crossing would require. The provision of the fat for the skin and clothing treatment. The replenishment of the specific thermal management material that the crossing had consumed was the specific thermal reprovisioning that the experienced expedition manager included in the shore stop's logistics. Chapter 12. The navigation. How staying on course reduced the cold. Exposure. Getting lost was a thermal problem. Not obviously. The modern person who thinks about navigation error on the open ocean thinks primarily about the directional problem of the missed landfall and the extended passage. But the extension of the passage beyond the planned duration was also the extension of the cold exposure beyond the provision's capacity to sustain it. The voyage that took 20 days instead of 10 was the voyage that had consumed the provisions designed for 10 days. And that was extending the crew's cold exposure into the range, where the accumulated thermal depletion became the specific survival level challenge. The Norse navigation was the specific empirical technology of the people who had solved the North Atlantic navigation problem without the magnetic compass, without the GPS, and without the specific mathematical navigation tools that the subsequent centuries developed. The Norse navigator's toolkit was the toolkit of the specific accumulated observational knowledge. The sun compass, the stars, the birds, the whales, the specific color changes of the ocean that the experienced navigator read for the proximity of land masses, and the specific current patterns that the Norse ocean geography produced. The sun compass, the specific circular device that the Norse navigator used to track the sun's position and determine the ship's heading relative to the sun's azimuth, was a specific navigational technology that the archaeological and textual evidence identifies as the primary Norse navigation instrument for the open ocean crossing. The sun compass used the shadow of the central gnomon and the specific seasonal correction that the Norse navigator applied for the sun's changing azimuth through the year to maintain the heading that the crossing required. The solar stone, the specific optical crystal that the Norse navigator may have used to locate the sun through the overcast sky that the North Atlantic frequently produced, was the specific navigational technology that the Norse sagas mention, and that the modern analysis of the optical properties of the Iceland spar, the transparent calcite that is found in Iceland and that polarizes light in the specific way that allows the location of the sun's position through cloud cover, has confirmed as a genuine functional navigation tool. The navigator who could locate the sun through cloud cover was the navigator who could maintain the heading that the sun compass required, and the navigator who could maintain the heading was the navigator who reached the intended landfall on the planned schedule, rather than the extended passage of the navigator who was lost. The star navigation was the specific nighttime navigation technology of the Norse crossing. The use of the specific bright stars and the specific constellation positions that the experienced Norse navigator had learned as the navigation reference for the specific latitudinal range of the North Atlantic crossings. The North Star, the specific fixed point of the Norse night sky, whose altitude above the horizon indicated the ship's latitude, was the primary nighttime navigation reference, and the Norse navigator who maintained the North Star at the specific altitude that the intended course required was the navigator maintaining the specific latitude of the intended crossing. The bird navigation was the specific environmental reading that the experienced Norse navigator employed as the proximity indicator for the unseen landmass. The specific bird species of the North Atlantic, the puffin and the gannet, and the specific seabirds whose daily foraging range limited their distance from land were the specific biological indicators of the landmass's proximity that the navigator who knew the bird behavior could read as the navigation supplement that reduced the uncertainty of the approach to the landfall. The current navigation was the specific oceanographic reading of the experienced Norse navigator who had learned the specific current patterns of the North Atlantic crossing. The specific drift of the Erminger Current and the East Greenland Current, and the specific circulation patterns that affected the passage in the ways that the experienced crossings navigator had mapped through the accumulated voyages. The navigator who understood the current was the navigator who could use the current as the navigation reference, the specific direction indicator and the specific speed modifier that the current's effect on the vessel's track provided as the navigation supplement. The accumulated navigational knowledge was the specific cultural technology of the Norse seafaring tradition. The specific, careful recording and transmission of the navigation information from the experienced navigator to the apprentice, the oral tradition of the voyage description that included the specific observational details that the next generation of navigator required to repeat the crossing. The saga literature that described the great voyages was not only the cultural celebration of the heroic achievement, it was the specific, practical navigation record that preserved the specific observational details of the successful crossing for the use of the subsequent navigators. Chapter 13, the equipment, the specific gear that every Viking sailor carried and why each piece mattered thermally. The sea chest was the thermal system in a box. The specific rectangular wooden chest that each Norse seafarer brought aboard as their personal equipment storage. The sea chest that was also the rowing bench, that was also the personal locker, that was also the seat at the oar position, contained the specific personal thermal equipment that the crossing required in the organized, accessible form that the confined space of the longship demanded. The organization of the sea chest was the organization of the thermal priority, the most immediately important equipment most readily accessible, the emergency equipment in the specifically known location that the emergency's urgency would require retrieval from without the deliberate search. The experienced Norse seafarer's sea chest was the organized equipment of the person who had thought about the sequences of need that the crossing might produce, and had organized the equipment accordingly. The primary sleeping skin was the primary thermal priority of the sea chest, the specific large piece of the insulating material that the sleeping period required, and that was too bulky and too heavy to wear as clothing, but was the single most important thermal equipment of the overnight period. The sleeping skin was packed at the top of the chest, most accessible, first out when the sleeping period required it. Because the delay of a misorganized sea chest in the transition from the active watch to the sleeping position was the delay of the time when the cooling body required the insulation that the sleeping skin provided. The additional clothing layer was the secondary thermal priority of the sea chest. The spare tunic, the additional hose, the additional layer, that the worst conditions might require beyond the standard sailing kit that the sailor wore. The experienced Norse seafarer who had crossed before knew the conditions in which the standard kit was insufficient, and the additional layer was the difference between the manageable and the dangerous, and they packed the additional layer accordingly. The fat provision, the specific personal supply of the animal fat for skin and clothing treatment that the sailor maintained separate from the ship's communal provisions, was the personal thermal maintenance material that the sea chest contained. The sailor who maintained the fat supply was the sailor who could treat the clothing and the skin at the intervals that the conditions required rather than waiting for the communal provision to be allocated. The personal fat supply was the thermal self-sufficiency that the experienced sailor valued. The repair materials for the clothing, the specific small supply of the thread and the needle, and the spare fabric patches that the sailor's clothing might require during the crossing, were the specific maintenance materials that the sea chest included for the thermal maintenance function. The torn garment that was not repaired was the garment whose thermal performance was reduced by the specific torn area through which the cold air could infiltrate the clothing system. The sailor who could repair the tear at sea was the sailor who maintained the clothing's thermal integrity throughout the crossing. The personal water container, the specific smaller drinking vessel that the sailor carried separately from the shared ship's water provision, was the equipment that allowed the personal hydration management that the crossing's exertion required. The hydration and the thermal management were the connected systems. The dehydrated body was the body whose thermoregulation was impaired, whose ability to maintain the core temperature through the shivering mechanism was reduced, and whose cold weather performance was compromised by the specific physiological effects of the inadequate hydration. The hand tools, the specific practical tools that the sailor might need for the vessel's maintenance during the crossing or for the practical tasks of the shore stop, were the sea chest contents that the thermal management did not directly require, but that the indirect thermal management of the vessel's integrity made necessary. The vessel that could be repaired at sea was the vessel that did not sink, and the vessel that did not sink was the vessel whose crew did not enter the 4-degree water, and the avoidance of the 4-degree water was the specific, most important thermal management outcome of the crossing. The personal weapon, the knife at minimum, the sword, or the axe for the warrior, was the sea chest content that the specific cultural context of the Viking age required, but the knife's thermal management function was the knife's specific practical use in the cutting of the lashings and the ropes and the other fastenings that the emergency management of the tent cloth and the shelter arrangement might require in conditions that made the deliberate untying impractical. The knife was the emergency thermal management tool, as well as the weapon and the general utility instrument. Chapter 14. The extreme cases, the Greenland crossing and what it meant for thermal management. The Greenland crossing was the worst one, not the worst in the sense of the most militarily dangerous or the most politically consequential, in the specific thermal sense of the crossing that required the most demanding cold management of any of the standard Norse sea routes. The crossing that pushed the Viking thermal management system to its most tested limit, and that the people who made it successfully had reached the specific farthest extent of what the Norse thermal management tradition could sustain. The Greenland crossing from Iceland, the specific approximately 500-mile passage that took the settler or the trader from the west fjords of Iceland to the settlement areas of Greenland's western coast, was the crossing that the Norse navigation tradition called the most dangerous in the Norse Atlantic. The specific danger was not primarily the weather, though the weather was genuinely severe. The specific danger was the latitude, the crossing that ran at approximately 65 to 66 degrees north, within the Arctic Circle, through waters whose temperature was consistently lower than any of the other standard Norse routes. The water temperature of the Denmark Strait, the specific Døgn oceanographic body of water through which the Greenland crossing passed, was the water temperature of the Arctic influence, the cold water that the East Greenland current carried from the Arctic Ocean southward along Greenland's eastern coast, and that the surface temperatures of the Denmark Strait reflected in the specific low values of the waters that the Greenland-bound sailor had to cross. The ice was the additional thermal hazard of the Greenland crossing that the Mediterranean and the British routes did not present. The sea ice that the East Greenland current carried southward from the Arctic Ocean, the specific pack ice, and the drifting ice of the seasonal cycle, was the hazard that the Norse navigator reading for the Greenland crossing had to identify and avoid, and the specific navigational challenge of the ice avoidance was the challenge that added the uncertainty of the ice's position to the standard navigational uncertainty of the open ocean crossing. The crew that made the Greenland crossing was the crew that had prepared with the specific awareness of the crossing's demands, the additional sleeping skin provision, the additional fat supply, the specific additional food provision for the potentially extended crossing that the ice conditions might impose. The Greenland crossing was not the crossing of the unprepared or the unprovided. It was the crossing of the crew that had specifically planned for the specific thermal demands of the most demanding route in the Norse Atlantic. The settlement that the Greenland colonists built on the western coast was itself a testament to the Norse cold management tradition. The specific architectural intelligence of the people who had learned to build for the Arctic winter that the Greenland settlement required. The longhouse of the Greenland settlement was the specific, thick-walled, earth-insulated structure of the cold climate architecture that the Norse traditions had developed for the most demanding cold management requirement. The Greenland Norse, who survived for 5 centuries in the specific, demanding conditions of the Greenland climate, were the people who had applied the thermal management tradition of the Norse seafarer to the specific challenge of the permanent Arctic settlement. The skills they brought from the longships' thermal management, the wool system, the fat application, the communal sleeping, the fire management, the food provision for thermal performance, were the skills that the Greenland settlement required in their most demanding form. The eventual extinction of the Greenland Norse settlement, the specific, still debated disappearance of the Greenland Norse colony in the 15th century, was not the failure of the thermal management tradition itself. It was the specific intersection of the climatic deterioration of the Little Ice Age, the decline of the trade routes, the specific social and political changes in Norway that reduced the support for the remote colony, and the specific population dynamics of the isolated settlement that eventually reduced the critical mass below sustainable level. The thermal management tradition that had sustained the colony for 5 centuries was not what failed. It was the economic and demographic support structures that the thermal management tradition required. Chapter 15, The Legacy, what the Viking thermal management tradition left behind and where it lives today. The wool is still doing the same thing. The specific molecular structure of the wool fiber that the Viking sailor relied on for the thermal management of the North Atlantic crossing is the same molecular structure that the modern merino wool base layer manufacturer describes in the technical specification sheet of the contemporary outdoor garment. The mechanism is the same. The moisture absorption without the wet feeling, the maintained insulation in the wet condition, the specific odor-resistant properties of the naturally antimicrobial fiber, and the performance that the modern wool garment delivers in the cold, wet outdoor environment is the performance that the Viking sailors' empirically selected textile was delivering in the same environment 1,000 years ago. The outdoor industry had to rediscover this. The mid-20th century synthetic textile revolution produced the specific cultural and commercial narrative in which the synthetic fiber, the nylon and the polyester, and the specific high-performance synthetics of the outdoor equipment industry was the superior alternative to the natural fiber that tradition had used and that science would improve upon. The synthetic base layer was the garment of the modern, technically informed outdoor person. The wool base layer was the garment of the old-fashioned person who hadn't read the technical specifications. Then the merino wool revolution happened. The specific commercial rediscovery of the wool fibers, specific outstanding performance properties in the cold, wet outdoor environment that the synthetic alternatives didn't match in the specific dimensions that mattered for the extended outdoor use. The merino wool base layer market that has grown substantially since the 1990s is the market of the people who have rediscovered, through the specific practical test of the outdoor use, what the Viking sailor knew through the specific practical test of the North Atlantic crossing. The fat application has its direct descendant in the modern equivalent of the lanolin-based skin and clothing treatment, the specific modern waterproofing technologies that the outdoor garment industry applies to the surface of the wool and other outdoor textiles to maintain the water-shedding performance that the Viking sailor's fat application was providing. The modern DWR coating, the durable, water-repellent finish that the contemporary outdoor garment manufacturer applies to the outer surface of the technical garment, is the specific engineered version of the fat treatment whose functional performance is identical and whose chemical mechanism is different. The layering system of the modern outdoor clothing industry, the base layer, the mid-layer, the shell layer, is the specific formal version of the Viking sailors' empirically derived layering system. The modern outdoor equipment industry has added the technical names, the specific fabric specifications, and the carefully designed compatibility of the layer system, but the fundamental principle, the skin contact moisture management layer, the insulating middle layer, the wind and rain outer layer, is the specific functional architecture that the Norse seafaring tradition had developed through the empirical testing of the most demanding cold water environment available in the early medieval world. Mjø, the sleeping bag, is the specific modern equivalent of the Viking sailors' sleeping skin, the insulating envelope that the sleeping body occupies for the specific overnight thermal management of the cold environment. The modern sleeping bag's specific technical development, the down filling, the synthetic alternatives, the mummy shape that reduces the unoccupied volume, the draft collar that prevents the warm air from escaping at the neck, are the specific engineering refinements of the fundamental concept that the sleeping skin represented in its Viking original. The emergency heat sharing technique that the cold water survival training teaches, the specific field technique of placing the hypothermic person between warm bodies for the direct heat transfer, is the specific direct descendant of the Viking sailors' cold emergency response that we discussed in the crew chapter. The technique works because the physics have not changed since the Viking Age. The warm body transfers heat to the cold body through the direct contact, and the cold body benefits from the warm body's metabolic heat production in the specific way that the physics of heat transfer requires. The Aran sweater of the Irish tradition, the specific densely knitted wool garment of the North Atlantic island tradition, is the specific cultural artifact of the maritime thermal management tradition that the Norse influence and the common North Atlantic environmental challenge produced in the specific form of the fishing community garment. The Aran's specific textured pattern, the cables and the diamonds, and the various stitch patterns that the different Aran families developed, is not merely decorative. The specific textures increase the loft of the knitted wool, and therefore the insulating air content of the garment, providing the specific thermal performance advantage of the textured surface over the flat surface that the knitter who understood the thermal function of the texture was producing alongside the aesthetic function. The Norse contribution to the modern world's understanding of cold weather survival is the contribution of the empirical testing laboratory of the North Atlantic. The specific, unforgiving environment that selected for the effective thermal management techniques and against the ineffective ones with the specific, rapid, decisive feedback of the environment that kills people who get it wrong. The techniques that the Viking sailor developed were the techniques that had been tested in the most demanding available test environment and had been found adequate by the specific, unambiguous standard of the survivor's return. Chapter 16. The Children. How Viking children survived the crossing and what the colonization. Voyages demanded of the youngest crew members. The child on the longship was not a passenger, not in the modern sense of the word, not the specific protected category of the person who has purchased the ticket and whose comfort and safety is the responsibility of the carrier's professional obligation. The child on the Viking colonization voyage was the specific, small, thermally vulnerable member of the traveling household, whose presence on the vessel was the presence of the family unit that was moving its entire life across the North Atlantic to the new settlement, and whose thermal management was the responsibility of the adults who had brought them aboard, and whose survival on the other end was the point of the voyage. The colonization voyages, the specific class of Viking sea journey that was distinct from the raiding voyage and the trading voyage in its composition and its purpose, were the voyages that carried children. The raiding crew was the crew of the fighting age male, selected for the specific physical and martial qualities that the raiding required, and from which the child was excluded by both the practical logic of the operation and the social convention that the culture maintained. The colonization voyage was different. It was the household in transit, the specific, complete social unit of the Norse farm family that had decided to take the specific, enormous risk of the ocean crossing in exchange for the specific, promised benefit of the land that the established settlement areas of Norway could no longer provide in the quantities that the expanding population required. The child's specific thermal vulnerability on the longship was the vulnerability that the medieval castle chapter's discussion of the infant's thermal situation addressed in a different context, but whose physics were the same physics. The smaller body with the larger surface area to volume ratio, losing heat faster than the larger body in the same ambient temperature, requiring the specific additional insulation and the specific management attention that the adult did not require to the same degree. The child who was cold on the longship was the child losing heat at a rate that their smaller metabolic output could not compensate for without the specific additional intervention of the adult's management. The infant on the colonization voyage was the most thermally demanding management challenge of the household in transit. The infant who could not regulate their own body temperature, the specific developmental stage of the very young child whose thermoregulation had not yet reached the adult efficiency, was the infant whose survival through the crossing was the survival of the fully managed thermal situation. The Norse mother who was crossing the North Atlantic with an infant was the Norse mother performing the specific, continuous thermal management of the body that could not manage its own temperature in the specific conditions of the North Atlantic Passage. The swaddling that the medieval castle chapter described as the standard infant management technique was the same swaddling that the Norse colonization voyage employed. The specific, comprehensive wrapping of the infant's body in the linen and wool layers that reduced the exposed surface area and maintained the warmer microenvironment of the wrap against the colder ambient temperature of the longship's deck. The swaddled infant on the longship was the infant whose thermal situation was as managed as the available materials permitted, tucked against the mother's body in the specific direct heat transfer arrangement of the nursing mother and the nursing infant that was both the feeding relationship and the thermal relationship of the body warmth transfer. The older child, the child of 5 or 6 or 8, who is past the nursing stage but not yet the functional crew member of the older adolescent, occupied the specific intermediate position of the person who was thermally vulnerable enough to require the adult's management attention, but physically capable enough to participate in the specific active strategies of the thermal management that the cold required. The child who was told to run, to move, to jump, to perform the specific active movement of the exercise that the body heat generation required, was the child whose adult was applying the specific metabolic heating strategy of the physical activity to the problem of the child's declining core temperature. The Norse tradition of the early childhood hardening, the specific cultural practice of the progressive exposure of the child to the demanding conditions of the northern environment as the preparation for the adult life that those conditions would impose, was the cultural practice that the colonization voyage accelerated by necessity rather than by gradual design. The child who crossed the North Atlantic at the age of 7 was the child receiving the specific, intensive course in the cold management that the gradual hardening of the shore-based upbringing was designed to provide over the first decade of life. The sleeping arrangement for the children on the colonization voyage was the sleeping arrangement of the maximum thermal efficiency. The specific communal sleeping of the family unit that placed the children in the center of the adult sleeping configuration, surrounded by the body warmth of the adults whose metabolic heat supplemented the children's own generation. The specific Norse domestic sleeping tradition of the communal family bed, the large sleeping space of the longhouse in which the entire family slept in the specific proximity of the body heat sharing arrangement, was the shore-based practice that the colonization voyage replicated in the confined, tent-cloth-covered space of the longship's overnight arrangement. The feeding of the children on the crossing was the thermal feeding as well as the nutritional, the specific calorie-dense provisions that the Norse infant and child management tradition identified as appropriate for the cold weather requirements. The breast milk of the nursing mother was the thermal provision that the infant required in the specific form of the warm liquid delivered at body temperature, the one hot provision that the fire-free longship could provide for the infant, whose warming effect was as real as the nutritional benefit, the dried fruit and the skyer, and the specific soft provisions that the older child could eat were the provisions that maintained the child's metabolic fuel supply for the heat generation that the crossing required. The specific mortality of the colonization voyage's children, the children who did not survive the crossing, is the specific dark dimension of the colonization statistics that the saga literature tends to underreport, and that the specific demographic analysis of the Norse settlement patterns partially reveals. The settlement that arrived in Iceland or Greenland with fewer children than had departed was the settlement that had experienced the specific thermal attrition of the most vulnerable members of the colonization party during the crossing. The colonization voyages' children were the specific high-risk members of the traveling group, and the Norse family that brought its children successfully across the North Atlantic and established the settlement on the other side had demonstrated the specific, competent thermal management that the children's survival required. Chapter 17. The Sick. How illness on the longship became a thermal emergency, and what the Norse tradition did about it. The fever on the open ocean was the specific medical emergency that the longship had no facility to manage adequately, and every reason to manage urgently. The specific physiological paradox of the fever in the cold environment was the paradox that the Norse seafarer encountered in the specific, difficult form of the person who was simultaneously generating too much internal heat, the specific elevated metabolic rate of the immune response that the fever represented, and losing too much external heat to the cold. Wet environment of the North Atlantic crossing. The feverish sailor was the sailor whose core temperature was elevated above normal, but whose peripheral temperature was dropping in the specific pattern of the fever's peripheral vasoconstriction. The blood vessels at the skin and the extremities contracting to retain the heat at the core, producing the specific simultaneous experience of the internal burning and the external shivering that the fever's physiology generates. The management of the feverish sailor on the longship was the management of the specific competing thermal demands of the condition. The need to allow the fever to work as the immune response. It was while preventing the specific dangerous escalation of the fever to the temperature that compromised the brain function and the heart function that the severe, unmanaged fever produced. The Norse tradition did not understand the fever in the immunological terms of the modern medicine. The fever was not the immune system's elevated metabolic response to the pathogen in the Norse understanding. But the Norse tradition did understand the fever's specific behavioral signs and the specific practical management that the experience of the sick person in the demanding environment had taught the Norse caregiver to apply. The cooling of the fever through the seawater application was the specific emergency technique that the longship environment made available as the primary fever management tool. The seawater that was otherwise the thermal enemy, the specific cold, wet substance that the sailor's entire thermal management system was designed to exclude, was the specific useful resource of the fever management situation. The cold, wet cloth applied to the forehead and the neck and the wrists of the feverish sailor in the specific traditional technique that reduced the skin temperature and provided the specific cooling relief that the fever's uncomfortable heat demanded. The sick sailor's position on the vessel was the specific protective management of the person whose thermal vulnerability had been increased by the illness beyond the normal range of the healthy sailor's management requirement. The sick sailor was the sailor moved to the most sheltered position of the tent cloth enclosure, the specific central position that the communal sleeping arrangement reserved for the most vulnerable, the position surrounded by the greatest number of warm bodies, whose collective heat supplemented the sick person's own generation. The sick sailor was not left at the exposed end of the sleeping arrangement, in the position appropriate to their crew rank. The thermal emergency of the serious illness overrode the social convention of the rank-based position allocation. The specific practical nursing of the sick sailor on the longship was the nursing of the person who had the minimum of the medical resources that the shore-based care could provide, and the maximum of the practical care that the crewmate's specific communal obligation required. The water was available. The specific hydration that the fever's elevated fluid loss required was the specific practical care that the crewmate providing the regular drink from the water provision was delivering. The covering was available. The additional sleeping skin from the crewmate's provision was the specific thermal care of the person whose fever's sweating and whose cold exposure's management required more insulation than the standard provision. The human presence was available. The crewmate who sat with the sick sailor through the watch period was providing the specific monitoring care that the serious illness required. The Norse medical tradition, the specific accumulated knowledge of the Norse healer, the völva, or the experienced farm wife, whose medical knowledge was the empirical knowledge of the person who had managed the sick in the cold environment for their entire adult life, was the medical tradition that the colonization voyages household included in the practical knowledge of the adults who had cared for the sick at home. The specific herbal preparations that the Norse medical tradition employed, the preparations that the shore-based healer had assembled from the plants of the Norse landscape, were the preparations that the provision voyage might carry in the specific, dried and preserved form that the sea voyage storage permitted. The specific Norse concept of the healing, the hold, the specific Norse term for the protection and the wholeness that the healing restored, was the cultural framework that the sick sailors' crewmates applied to the specific practical care they were providing. The healing was not only the medical intervention, it was the specific social attention of the community to the vulnerable member, the collective recognition that the sick person required the specific additional care that the collective could provide and that the individual could not manage alone. The crewmate who sat with the sick sailor was not merely the medical attendant. They were the specific social expression of the collective obligation to the vulnerable member that the Norse ship companion tradition required. The specific mortality of the sea voyage's illness, the sailor who did not survive the crossing because the specific combination of the illness's physiological demands and the crossing's thermal challenges exceeded the body's capacity to manage both simultaneously, was the mortality that the Norse seafaring tradition acknowledged as the specific unpreventable risk of the sea crossing in the conditions that the North Atlantic produced. The saga literature that recorded the great crossings recorded also the specific deaths of the voyage, not with the specificity of the cause of death that the modern death certificate requires, but with the specific matter-of-fact acknowledgement that the voyage had cost specific lives, and that those lives were part of the cost of the crossing that the Norse tradition had accepted. The recovery of the sick sailor, the specific physiological event of the illness's resolution during the crossing, was the recovery managed by the same thermal care that the illness's acute phase had required. The person who was recovering from the fever was the person whose reduced food intake during the illness's acute phase had depleted the metabolic fuel reserves that the cold management required, and whose refeeding during the recovery was the specific thermal refueling of the body's heat generation capacity, as much as the nutritional restoration of the depleted tissue. The crewmate who ensured the recovering sailor ate the provisions that the recovery required was the crewmate performing the specific thermal care of the person whose recovery depended on the metabolic fuel as well as the rest. Chapter 18. The Sea Aventuries. Women, the specific, complicated reality of the female experience on the Viking crossing. and how women managed the thermal challenge. The Norse woman was on the ship, not as the passenger of the protected category, whose presence on the vessel required the specific, separate management of the person who did not belong to the operational crew, as the member of the colonization voyages household, whose presence was the presence of the person who was moving their life, their skills, and their specific practical knowledge of the cold management that the Norse domestic tradition had given her to the new settlement on the other side of the crossing. The mythology of the Viking Age has a woman problem that is the opposite of the mythology's typical omission. The popular mythology of the Viking Age has overcorrected from the historical invisibility of the Norse woman by producing the specific modern version of the Shield Maiden, the fully armed, fully capable, fully equal female warrior of the contemporary entertainment media, whose existence the historical record partially supports in the specific, exceptional cases of the women who did take up weapons and who the saga literature records. The overcorrection has produced the specific, false impression that the Norse woman's primary contribution to the Viking Age was the military contribution that the Shield Maiden represents, when the historical reality was considerably more complicated, and the thermal management dimensions of the Norse woman's contribution were considerably more important to the actual daily survival of the Norse people than the Shield Maiden mythology acknowledges. The Norse woman was the textile expert, not incidentally, not as the domestic craft that the unimportant domestic work of the period's women produced, but as the specific critical technology holder of the thermal management system that the cold water survival depended on. The wool's journey from the sheep's back to the sailor's garment was the journey through the specific skilled operations of the Norse textile tradition, whose practitioners were primarily women: the shearing, the washing, the carding, the spinning, the weaving, the finishing, and the specific thermal performance of the final garment was the direct consequence of the specific technical skill that the woman who made it had applied to each stage of the production. The woman who spun the wool for the sailor's garment was making the specific thermal decision of the thread's twist and the thread's diameter that would determine the weave structure's loft and the final garment's insulating capacity. The woman who wove the garment was making the specific thermal decision of the weave structure, the twill or the plain weave, the beat density, the warp and weft spacing that would determine the garment's wind resistance and its water shedding capacity. The woman who finished the garment was making the specific thermal decision of the fulling and the napping, the processes that closed the weave structure and raised the surface fiber that increased the insulating air content of the textile. These were not simple decisions. They were the specific, accumulated technical knowledge of the Norse textile tradition, whose practitioners had developed the specific empirical understanding of what textile properties produced, what thermal performance in the specific conditions of the cold, wet environment that the Norse seafarer operated in. The woman who was producing the best garments, the garments whose thermal performance the experienced sailor recognized as the superior product, was the woman whose specific technical knowledge had been developed through the specific long apprenticeship of the tradition that the Norse domestic culture had built around the textile production. The woman on the colonization voyage was carrying this knowledge across the North Atlantic in the specific form of the practical skill that the new settlement would require to produce the textiles that the new settlement's survival needed. The settler who arrived in Iceland or Greenland without the person who knew how to produce the cold weather textile was the settler who was dependent on the supply from Norway for the thermal management equipment that the settlement's survival required. The settler who brought the textile knowledge, the woman whose spinning and weaving and finishing skills could produce the garments that the settlement needed from the wool of the sheep they were also bringing, was the settler who was carrying the specific critical technology of the cold management tradition to the new location. The woman's own thermal management on the crossing was the thermal management of the person who was simultaneously managing their own thermal situation and managing the thermal situations of the children and the other dependent members of the household in transit. The Norse woman on the colonization voyage was the specific multitask thermal manager of the family unit, the person whose attention was distributed across the thermal states of the multiple vulnerable members of the household, while managing her own thermal maintenance with whatever portion of her attention and resources remained. The Norse woman's clothing was the same wool system that the male sailor's clothing employed, with the specific adapted form that the female garment tradition had developed for the woman's body and the woman's activities. The apron dress, the specific outer garment of the Norse woman that was suspended from the shoulders by the specific paired brooches that the archaeological record has preserved in considerable abundance, was the garment worn over the linen inner dress in the specific layered arrangement that the Norse woman's cold management system employed. The wool of the apron dress was the same insulating wool of the male tunic. The layering principle was the same. The specific thermal function was the same. The head covering was the specific thermal management element of the Norse woman's cold weather kit that the nightcap chapter of the medieval castle script discussed in a different context, but whose thermal significance was the same significance. The wrapped linen head covering of the Norse woman. The specific textile arrangement that the Norse female dress tradition required for the adult woman, and that covered the head and the neck in the specific insulating arrangement that the head's significant heat loss required addressing, was the garment that the female sailor's cold management relied on, as the male sailor relied on the nightcap. The woman whose head was covered on the crossing was the woman whose most significant surface heat loss was managed. The specific physical demands of the childbirth on the sea crossing, the rare but documented occurrence of the birth during the colonization voyage, was the specific thermal emergency of the highest order that the longship could face. The woman in labor on the longship was the woman in the specific physiological state of the highest metabolic demand, requiring the specific warm sheltered environment that the best available arrangement of the tent cloth and the sleeping skins and the collective body heat of the assisting women could provide. The birth at sea was the specific communal management of the female members of the colonization party, the specific collective knowledge of the Norse midwifery tradition applied to the specific inadequate physical facilities of the open deck vessel. Conclusion: the crossing, what all of this means and why it matters. It is still November. You are still on the ship. But you understand now what you did not understand at the beginning. The people around you are not the victims of the cold that they appear to be. The wet, cold, wind-exposed figures hunched over their oars or huddled under, the tent cloth in the specific patient misery that the crossing imposes. They are the practitioners of the specific sophisticated, empirically developed thermal management system that the North Atlantic had required them to develop, and they are practicing it with the specific professional competence of the people who have done this before and who intend to do it again. The wool is working. The wet wool that looks like it cannot possibly be doing anything useful is retaining 60% of its dry insulating value in the specific, quiet way of the material doing its job without announcement. The fat on the face is working. The waxy barrier of the animal fat that was applied this morning is reducing the evaporative cooling from the skin surface in the specific, imperceptible way of the protection that prevents the damage rather than reversing it. The rowing is working. The 30 men at the oars are generating 12,000 watts of metabolic heat in the specific, mechanical, beautiful efficiency of the coordinated human effort that the longship's design was built to harness. The tent cloth will work tonight. The heavy wool draped over the ship doors will create the specific, adequate windbreak that the sleeping crew requires, and the collective body heat of the sleeping 30 will maintain the interior temperature of the tent space at the specific, above dangerous level that the survival requires. The sleeping skins will work. The reindeer hide and the seal skin of the prepared sailor will provide the specific additional insulation of the personal thermal envelope that the collective tent warmth supplements but does not replace. The food is worked, the dried fish, and the hard cheese. And the skyr that the crew consumed this evening has fueled the specific metabolic heat generation that the night's rest will require. The Viking thermal management system was not the comfort of the centrally heated modern world. It was not the ease of the engineered, specified, tested outdoor garment of the contemporary adventure industry. It was the specific, adequate solution to the specific, genuine problem of the cold body in the cold environment without fire, assembled from the materials that the natural world and the Norse craft tradition provided, and operated with the specific practical intelligence of the people who understood that getting it right was the difference between the arrival and the absence. The crossing will take 5 more days. You will arrive wet, cold, tired, and alive. You will step onto the land and feel the specific, extraordinary pleasure of the ground that is not moving, and you will smell the fire that someone has already lit on the shore for you. You will drink the hot soup that the fire has heated, and you will sleep on the ground that is not the deck, and you will wake up in the morning, feeling the specific recovered warmth of the body that has been adequately fed and adequately sheltered and adequately rested for the first time in 8 days. And you will perhaps understand something about the people who did this regularly, who crossed the North Atlantic not once, but dozens of times over their careers, who treated the crossing as the professional challenge of their trade rather than the ordeal of their exceptional courage. They were not superhuman. They were not immune to the cold. They were not sustained by the mythological courage of the warrior culture alone, though that culture helped. They were the practitioners of the specific technical tradition of the cold water thermal management that the North Atlantic had required of the people who wanted to cross it and return. The wool knew what it was doing. The fat knew what it was doing. The rowing watch rotation knew what it was doing. The sleeping arrangement knew what it was doing. The food provision knew what it was doing. The Vikings knew what they were doing. And the North Atlantic, the specific, cold, indifferent, beautiful, lethal North Atlantic, that has been doing the same thing since long before the Viking Age, and that will continue doing it long after the last synthetic fleece is forgotten. The North Atlantic knew what it was doing too. It was trying to kill them. They managed not to let it. That, in the end, is the whole story.